Hello YouTube, welcome back. Hope you're doing well. So it's been a while since I've recorded a video, or rather my video recording schedule has gone down quite a bit. It's a little bit tough to keep up when you also have a real job and a quote-unquote real job, and also working on a side project that I'm not quite ready to talk about yet, but a large side project. But anyway, let's get back into it. So I think what we were thinking about last time was making the king and queen moves. Let me have a look. Yeah. And if we run the tests, they all seem to be fine. And now I think the only thing we need in our move generation function is to generate moves for pawns. And that one will be somewhat tricky. Now we should be able to do this. Let's go to generate king moves and put it underneath. So as always, we need the reference to a piece and the reference to a game, and it returns a vector of positions. And we'll mark it as to do and check that it compiles. Oops. Check that it compiles again. All right. So why are pawn moves tricky? They're tricky because en passant is possible. So the way I want to think about it is we first consider all possible moves. En passant is possible if the en passant field in the position is set, and once we have made a move, so let's say after making a move, we need to decide if the en passant field should be updated. And actually, in general, you know, en passant, the en passant field should be cleared after almost any move. So let's go into the position class, and there's the move piece function. And this one should actually set the en passant square, en passant field to empty, unless it's a very special case. So also, why is this code so dirty? Let's clean it up. So let's do something like perhaps, yeah, I think the en passant logic could fit in here. So let's first have a look at the piece type, and if it's a pawn, then we don't know what to do yet, but anything else, then we want to set, let me just check how it's defined. It's not an enum, it's a struct. Then we have to set self en passant to none, because if I move anything that's not a pawn, then if en passant was possible before, that's definitely not possible now. So we need to implement two things in this video. First, this function that just generates all the set of possible moves, and then the logic in here, which should basically be if the pawn moved 2 squares and it now has a neighboring pawn, set en passant. Okay, I think I'm gonna make a cut here and then just show you how it looks afterwards. Okay, so before I get too much ahead of myself, let's look at what I have right now. So first I just get the position index, I get the row and the column, I get the occupancies as normal, then I define this direction, which is the direction the pawn is moving in. You know, either the row count has to increase every time the pawn moves, so it has to decrease. Then what I need to do is often to look at, like, okay, we increase the row by 1, the column is the same, or if it tries to take a piece, the row will increase, the column will increase, and you know, things like that. So so I really want to use this row column format, but the positions I want to consider are these bitmaps. So I want to make some function that goes from row and column to bitmap, but or bitboard, but you know, there's all these corner cases where maybe this column plus 1 is outside the board. So my utility function here that I just called index is actually returning an option, and I realized now that actually we need to bit shift this guy. Now it should be correct. Let's try to check it again. Still works. So let's open it again over here. So because this guy is an option, it's a bit annoying when you have to push it to the vector of potential squares. So what I do is I define this macro that takes a vector and something that's maybe something, maybe it's nothing. You know, it's an option, so maybe it's some or maybe it's none. And then I just match on that, and if it is something, I push that something, otherwise I do nothing. Now I can use that down here to say, okay, push where the pawn is moving 1 square. Now, really this should always work, because the only case that this couldn't work is, the only case where this would be out of bounds is if the pawn was on the very end of the board, but in that case it should have been promoted. So maybe we should really do something else. Maybe we should just panic, you know, instead of returning none. That way we will at least, and also the same here. I mean, if the row is 2, we don't really need this check. We know that 2 plus 2 is less than 9. And now actually here is the only case where it's kind of nice when we try to take another piece. So you know what, I'm going to do something else. I'm going to keep the interface of returning an option, but now I'm going to unwrap it, or also we can give an error message. Pawn was somehow at the edge of the board. Something like that. Sure, there are better error messages. And the same thing here. just push that. But here I'm just going to unwrap it because there's no way that can, should be no way that could fail. And the same here. This one I actually do want it because, oops, I need to have an extra ampersand there. So what I'm doing here is first I check if this is a valid position. If it is a valid position and there's an enemy piece at that point, then I push that point. And the same here, but where I increment the column by -1 instead of +1. Okay. Now we have all the positions. Now we just need to make the moves. So let me see exactly how this move piece, not that one, move piece, it takes piece position and a U size. So actually that means that this one should return just the U size, and then we don't bit shift. I think that should do it, because this is just returning an index into, you know, from 1 to 64 instead of a bit board, so that should be fine. And then we can say positions you know, basically what we did up here, although we called it positions there, so why not do that here again. And this one we called new squares, why not? I'm not gonna rename that. So for potential move in new squares, the new position is the clone of the current one, but where we have moved the piece, and then we just return those. So let's check it compiles. Doesn't compile because now we don't use this anymore. Oh, it does compile, but it gives a warning, so let's move that. And now this checking doesn't work, so we need to do this and this. Okay, great. So it's not quite implemented yet because we still need this to do down here. And wait, also forgot to check for en passant. So let's just remind ourselves how it is actually defined. So we don't have it here. I think we have some en passant test down here. So I'm just, it must be that you can do an en passant and take this and go to this square. But another thing we need to implement is also removing the piece that was taken during the en passant. But anyway, let's see. So if let some square equal game dot position dot en passant, and what is the format of this? It is just a bitboard, Then we want to add that as a potential move. But actually, we need to handle that in a special way, I think. So let's say new position. And then we will say take en passant. And we want to move again this piece. And the new position is the square, which is kind of, we will leave it like this. But the interface will be a little bit weird. Okay. So I want to implement a function like this. But the new position will be also a bitboard or piece position, probably more correct to call it that. Even though it's a type synonyms for the same thing, it's a little bit more clear. Because a bitboard is supposed to be like indicating positions of several pieces. Okay. So what we need to do is move the pawn, take the other pawn, and clear en passant field. So we have that, and we also have this function. So let's start with this one. Okay, so this function that sets this part of the function that sets the en passant field now looks like this. It's a little bit messy, honestly, but this is what my tight brain could come up with now. So if the square index, which is where the piece came from, and the new position of the piece differs by 2 rows, which I've written like this, and probably this is like a very silly way to do it. So let's say old row and nothing, and I should have a utilities function for this. I thought I would have something like that, but I guess not. Let me make it. And here it is. So we just take an index and then we return the row and the column for that index. So we will say like this. I think it will make it a little bit more understandable what the heck is going on. So then if old row minus new row differs by 2, then we can also say that the direction is the new row minus old row, the sign of that. And then we have to determine whether there's a piece on, and it has to be actually a pawn. So let's say pawn left, and we will call a new function that just says, does a given square have a pawn? And we want to say, let's say old row plus 2 times direction and column plus 1 and column minus 1. And then we want to say if there is a pawn there or there is a pawn on the right, then self.en has to be index of new row. No, sorry. Let's old row plus 1 times direction, and the same column, so we need that as well. Stop. And that should do it. Otherwise, en passant should be set to none. And that's it. Can remove that. I think it's a little bit easy to understand. So let's say has pawn. We'll just take a reference to self. I think we can just write it like that. And it will take a row, I32, a column, which is an I32, return a Boolean, and we will simply check if the square and let's say what went wrong? Okay. Otherwise, it should be false. We'll assume by default it's false. So if so let's take the square and let's take the. We need to check if it's occupied or not. Piece index, and then we do something. Or if it's empty, then we return false. And if it's empty, then we return self.pieces.pieceindex.pieceType equals a pawn. I think that should be correct. Let's see. So expected U64, found U size. I am okay. Changing the type here. And it should be haspawn. And right, we need to unwrap this. I'm going to assume this is correct. And again, it wants a U size. Because we don't want the index, we actually want the bitmap position, bitboard. And again, I don't have a function for that. All right, let's just do it like this. Let index be this, and just cast it to U size, and then we say like so. Check it, and now it passes, or it checks. Now we should really write a test. And do we have a move piece test in here? Yes, we do. And after the piece is moved, I want to assert that game.ampersand wait, can you do this? Wait, like that. Okay. Let's also make a position where it actually actually has to set the ampersand field. And okay, to do this, I first defined this position to index that takes like a D4 or something like that string and turns it into an index. And then I set up a new position that has white pawn on D2, a black pawn on C4, so that if I move this white pawn to D4, then there should be an ampersand possible. If I run that, it fails. So for whatever reason, so let's just do some print debugging. It should hit this one. And does it do that? Yes, it does hit this. Now, does it hit down here? It does hit that one. But then the problem must be this pawn left and pawn right that doesn't work for some reason. Yeah. Let's say pawns. Yes, here it is. It's returning false. And let me just check the rows. Why am I doing it like this? Okay, so also correct. So we go down here and we should definitely hit down here, right? IDX is valid. And it also writes that IDX was valid. But it only writes it once. That's very interesting. So what is the column? The column is 8 for some reason. That means that there is a bug in this function. Because it's not and, it's modulus. Okay, great. Still it failed, but at least now it is still wrong because we need to +1 here. Okay, great. So now the tests are all passing and it should be correct. Now for the final thing, let's try to move this, let's try to take en passant. So as I was writing this take en passant function, I noticed a potential problem here, which is that we remove this piece from the list, take it out of the vector entirely. But that means that potentially, and like most often, a lot of these pointers or indices that we have in the squares will be invalidated. So really what we need to do is not to remove it. I mean, we could update all the pointers, but that's a little bit annoying. But instead, let's just set like a flag to tell it that it's been taken. So we never remove pieces that were taken. So it will make some of the tests fail. Not this one, but piece. Struct piece. But it is how it is. So I think we also instantiate these guys somewhere. And now, where do we do that? I guess the compiler will tell us when we get that far. But anyway, so what I was doing here is same as always. We find the square of where we're starting. We check that there actually is a piece there, otherwise we should panic. Then we change the position to the new position. We set the old square to empty. Then we check the new position. Is there something there? Now for en passant we need to actually panic if there is something there, because there shouldn't be. Otherwise we should be empty and we don't do anything. And actually we can also just do it like if let occupied something equal this, then we panic. It's a little bit better. And then again we need to find the piece to remove, which is the new row but going one step back, and the same column. And the index, then I find the index of that square, and if it's empty, then again there's some kind of mistake, because there should be a piece there. If it's occupied, then we need to remove that piece. And now here comes the reason why I found the bug. So then we just set it to false, and we also have to remember to set this one to empty. So we kill the piece that was living there, and then remove the pointer to it. And if we have taken en passant, it's impossible that there's en passant possible in the next move. It's impossible. Anyway, so now we need to add this new field that we made. Pieces are usually alive. And same here. I wrote it with capital, didn't I? Yes. And the same down here. And let's try to check it again. Okay. So what we need now, and what we will do in the next video, is a test for en passant, the take en passant function, and it is a test for this. We have a lot of tests. It's a test for generate pawn moves. But I think we have done enough for now, so see you next time.